The first cable we will splice is the 15 kV single conductor cable with a metallic tape shield. You should follow these same instructions for splicing lead sheath cables. Prior to sliding the nested tubes onto the cable, be sure to clean the cable surface with an oil-free solvent and a lint-free cloth for the length of the tubes. Then, after the connector is installed, remove any remaining burrs or sharp edges and clean it and the cable surface with solvent. Now cover the connector with stress relief material, commonly called SRM. Take a package of the SRM and remove one side of the protective paper. Then roll it up with the paper on the outside. This will make it easier to handle and will prevent it from sticking to itself. Start by wrapping the SRM between the connector and the insulation. As you wrap, keep the SRM stretched to half its original width and ensure that it completely fills in the gaps on both sides of the connector. When you heat shrink the first tube into place, the SRM will melt to fill in these gaps. Wrap the SRM around the connector until it is slightly larger than the outside diameter of the insulation. Finish it off by wrapping 1/4 inch onto the insulation and tearing off any excess. If the connector diameter is larger than the diameter of the insulation, you will need to apply no more than 2 half-lapped layers of SRM over the entire connector. Be sure to fill in the gaps between the connector and the insulation with SRM, as well as overlapping the insulation by 1/4 inch. Next, use the SRM that is diagonally cut to fill in both gaps at the edge of the semicon cutback. Lay the point of the SRM on the surface of the dielectric, up against the edge of the semicon cutback, and wrap until it is the same thickness as the semicon. Again, stretch it until it's about half its original width. With the last wrap, overlap it 1/4 inch onto the insulation and 1/4 inch onto the semicon. Now take the innermost black tube, which is the stress control tube, and center it over the connector. Then, using an appropriate torch, begin shrinking the tube. The flame should be about 6 to 8 inches in length, and the tip should touch the surface of the tube. Begin at the center of the tube and, with a painting-like motion, work the torch around, heating the tube on all sides. Once it is locked in place, slowly continue shrinking around the circumference towards the ends of the cable, keeping the torch at a 45-degree angle. This preheats the tube and pushes the air out, assuring a smooth, void-free interface. When you reach the end of the tube, move the torch to a 90-degree angle to the cable, making sure that the tubing has shrunk smoothly with a uniform wall thickness. Now, visually inspect the tube and check it with your hand to make sure the entire surface is smooth and uniform. You should reheat the tube to correct any imperfection. Next, position the red insulation tube over the stress control tube. This tube is designed to build up the cable insulation thickness on the splice. Use the same shrinking technique that was used on the first layer, beginning at the center and working toward the end. This tube will turn a darker color if you overheat it, but once you remove the torch, it should return to its normal color and you can continue heating. However, you should avoid any overheating that will scorch the tube. Again, check that there is a uniform wall thickness at the end and that the surface is smooth. Next, butt the red sealant up to the black stress control tube and wrap it to the same thickness as the red insulating tube that was just installed. This sealant is used to block any moisture that might enter the splice through a damaged cable jacket. You don't need to stretch this sealant during application, as it will melt and flow when heat is applied to the next layer. When installing multiple layers of tubing, make sure that the surface of the last tube is still warm before positioning and shrinking the next tube. The next layer is the co-extruded black and red tube. The interior red portion is insulating material, and the black outer surface is semicon material. Position it over the red insulating tube and shrink as illustrated before. It will take longer than the previous layers to shrink because of its heavier wall. When the shrinking is complete, the adhesive should flow onto the cable semicon, sealing this layer. You are now ready to install the grounding layer. First, install the fault current braid. This connects the copper tape on one side of the splice to the copper tape on the other side. Flare one end of the braid and place it on the copper tape facing away from the splice, and attach it with 2 wraps of the spring clamp. Now fold the braid back over the clamp and wrap using the remainder of the clamp. Next, secure the clamp using the copper foil tape that's included with the kit. Now stretch the braid across the splice and attach to the copper tape shield on the other side using another spring clamp. Lay the braid against the copper tape and secure it with 2 wraps of the spring clamp. Fold the braid over the spring clamp toward the splice and wrap using the remainder of the clamp. Secure the end of the clamp with copper foil, then cut off the excess braid. If the splice is to be externally grounded, a Raychem HVS EG kit should be used. Contact your local Raychem sales office for specific installation information. To install the ground on a unishield or drain wire cable, first fold the end of the braid and insert it into a suitable connector. Then pigtail the wires together and insert them into the fold of the braid. Crimp the connector and cut off the excess braid and wire. The next step is to install the shielding mesh. The mesh is an extra safety measure to ensure that the circuit breaker is tripped in the event the splice is punctured opposite the ground braid. Start at one end of the splice with a half lap of the mesh, then wrap it around the entire length. Finish by tying it with an overhand knot, making sure that it is overlapping the copper tape. Then cut off the excess. At each end of the splice, abrade the jacket and clean with solvent to improve the bond on the rejacketing tube. The next step is to shrink the rejacketing tube into place. This tube is pre-coated with adhesive, so when it shrinks, it will seal completely around the cable jacket at both ends of the splice. As the tube is heated, the adhesive will flow at the ends, indicating that the shrinking is complete. Check that the rejacketing tube has a uniform wall thickness and that there are no flat spots or dimples. Also, make sure the cable is cool to the touch before moving it or placing it into service. When all of the tubes have been properly installed, they'll provide stress control, insulation, shielding, a seal against moisture, and mechanical protection to the splice.